So here's our first lesson here in chemistry, is how to read a device that has a linear scale on it. A ruler is a device with a linear scale because you can see there's these lines and the spaces between the lines are the same, and so that's called a linear scale. Linear scales occur on many devices. Here's a graduated cylinder with a linear scale, a pipette with a linear scale, and many other things that we're going to use this year. When they put the lines on the linear scale, in this case the ruler, you have choices. And the top you can see are in inches, and there's nothing wrong with inches. The reason we're not using inches in this class isn't so much because the metric system's better. It's because on this ruler, the inch side is considered a fractional scale. A fractional scale has a situation where the lines between the numbers are cut in half. There's a half, and then cut in half again, there's a quarter, and cut in half again, there's an eighth, and cut in half again, there's a 16th. And that's different than on the decimal side that we have here. On the decimal side, it's in centimeters, because each device should have some kind of label of the type of unit that it is. You see this in centimeters, and you can see that between the 1 and the 0, there are 10 little spaces. Okay, 9 little lines, 10 little spaces. That's a decimal scale. And in science, we pretty much always use a decimal scale for reasons that we're going to talk about in this lesson, which are things about how you measure the uncertainty, which is how much error there might be in your measurement, and something called significant digits or significant figures that we'll get to in a second. So, our first example. Here's a block of wood, and I want to measure this block of wood. Let's say I want to measure the length of the block of wood. To do that, I have to bring in some kind of linear scale. So here's one that I have, and you can see that it's marked in centimeters. And I'm going to do my best to line up one edge of the block with my scale or my ruler. So you can see that every time you measure, there's this bit of uncertainty because you're just trying to line this up. Now, the camera makes it look less lined up than it is. See how when I look straight down on it, it looks lined up, and when I slide it over here, it doesn't look lined up from the point of view of the camera anymore. That difference in where it is based on how you or where you're looking from it is called parallax error. So you'll just have to trust me that this end over here is lined up as best I can. So what length should I put for the length of this piece of wood? Well, you can see that I have a space that's marked 10 centimeters and a space that's marked 20 centimeters. So the length of the wood is somewhere between 10 and 20. Since this is a decimal scale, you can see that it goes up 10, 20, 30, 40 as if it was counting by tens. I can use in my head, I can imagine little spaces, 10 little spaces and 9 little lines in between, and I will guess which one that lines up with as best I can guess. So it looks like to me, if I was to guess, let's see, that's about 15, so maybe that's 17, or maybe it's 16, and you'll have to guess. So that last decimal place, I'm sure about the 10 or the 16 or 17 of it, so I know that it's 10 and some more. I'm going to go ahead and guess 10 and 7, and those are centimeters. And I'm going to say that the place that I guessed, the 7, which is in the ones place, you might have said it was a 6. So I'm going to put in my measurement this little sentence or this little notation that says that decimal place there, we may disagree on. And that's okay. And the simplest way to decide how much room for error there is to take the decimal place that you guessed and make the error 1 unit in that decimal place. This quantity right here, the amount of room for error, is called the uncertainty. And as we start this course, every measurement will have an uncertainty. Now, I'm not going to change the block of wood, but I'm going to change the scale. So here's the same ruler, And I'm going to try to line it up. I've got this end where my thumb is lined up well, and I'm going to try to line up the camera with this end so that we can sort of look straight down on the ruler, because it's important when you measure to look straight down to eliminate parallax error. Well, you can see now that the block of wood is larger than 17. So my guess of 17 wasn't that bad. But now I can make an even better guess. So the big question, or the big point of today, is why can I make a better guess now? Well, the ruler now has actual lines in the 1, 2, 3, 4. These little lines in between, which are the halfway marks, I'm going to kind of ignore. And I'm going to say, I know the ones place for sure now. So when I look at this measurement, I know it's 17 and a little bit more. So I'm no longer guessing this 7. I know it for sure. So on this ruler, I would say, let's see, it looks like it's 17, and well, I'm going to have to put another decimal place now. So if I do the same trick and imagine 10 little spaces, that looks like it's about 2/10. So I'm going to put 17.2 centimeters, but now my guess is a different decimal place than it was originally. I'm now certain about the tens place, certain about the ones place, and pretty certain about the tenths place, okay, which means the tenths place could be off. We may disagree, so I'm going to put plus or minus 1/10 of a centimeter as my uncertainty, so that if someone else comes along, they can tell, wow, the 2 is their best guess based on the ruler. If the ruler has even more lines, then it changes your ability to guess once again. So your first task is to decide what decimal places are known for sure. On this ruler, it looks like I have the ones place and the tenths place, because there's 10 little spaces between the 2 and the 3. That means on this, using this side, I would guess, well, let's see, I know the tenths place, so I would guess the hundredths place. Going back to the ruler we just had, I knew the ones place, so I was able to guess the tenths place. And when I only knew the tens place, I had to guess the ones place. That's basically how linear scales work, is you have to determine which decimal place is the one that was known for certain and which one was guessed. There's another word at the top of our little lesson, and that's uncertainty and significant digits. Significant digits are the digits that were actually measured. So in the 17 one I had here, where I knew the 1 for sure and I guessed the 7, that means I knew 2 different decimal places. I knew the tens place and I knew the ones place. At least I was pretty sure about that. So I would say I guessed 2 decimal places. I would call those 2 significant digits, or we'll call them significant figures, or sig figs for short. In this measurement, I knew the tens place for certain. This one I knew the ones place for certain, if you recall. See, I knew the ones place for certain, and I guessed the tens place. That means I knew the tens, the ones, and the tenths, or 3 decimal places, and so we would say 3 significant figures. Okay. The uncertainty and the number of significant figures will be really important when we use calculators with measured numbers, because we're going to have to round off our calculator answers based on either the uncertainty or the significant figures. We'll learn how to do that later. So here's a couple for you to try. In this second example, or this first one for you to try, we have 2 different graduated cylinders with some colored solution. It's just basically water with food coloring. You can see, though, that on this graduated cylinder, I know, let's see, which decimal place for sure. It looks like I have the tens place is written, and I have lines for the ones place. So you'll have to decide what decimal place will be guessed if I know for certain the tens place and the ones place. On the other graduated cylinder, It looks like I know, well, that's kind of zoomed in. Looks like I know, let's see, 300 is right there. And that's 400 and 500. And I know the spaces in between. So let's see, if that's 500 and that's 600, each little space must be worth 10. So on this large graduated cylinder, I know the hundreds place, and I know the tens place, and so I'll have to decide which place to guess. So I'm going to pause for a second, or I'm going to have you pause, and try to just write down what you think that measurement is for each graduated cylinder. Okay, so there's the two measurements. Do the best you can to record what you think those volumes are. Okay, let's see how you did. If I can get the camera to work. So, on this first one, the smaller graduated cylinder, well, we're going to have different answers for each one. They have different amounts of water, but they're also going to have different decimal places. So you can see on this first one, I know that it's above the 40 and below the 50. It looks like it's almost right on the 42. In fact, I think it's right on the 42. The bottom of the little bubble is called the meniscus, the bottom of the meniscus. So I think it's right on the 42. Is it exactly 42? No, you cannot have exactly a volume because A, you're using a piece of glassware that was made somewhere that and isn't super accurate or precise. And so you're doing the best. In fact, every measurement you make is going to be a guess. So on this graduated cylinder, if I thought it was right on the 42, I should put, let's see if I can write it right here, 42 for sure. And I know the ones place, so I must guess the tens place, and I think it's right on the line. So I'll put 0.0. And these are, if I look on the graduated cylinder, milliliters. That means I've guessed the tenths place. And that 0, although it won't matter in a math class, really matters in this class because that 0 there says I measured, or at least I'm pretty sure about the number, that's in the tenths place. That would be plus or minus 0.1 milliliter because that tenths place is what I guessed. And I would say it has 3 significant figures. On the larger graduated cylinder, it looks like, let's see, wait for that to stabilize. It's, let's see, 510, 520. It's just below the 530 from where I'm standing. The bottom of the meniscus. So I'm going to call it, let's see, if I know the hundreds place and the tens place, I can guess the ones place. So I'm going to say, I think it's right about 529. 529 milliliters. Now on this measurement, there is no tenths place because the ones place is what I guessed. So that would be plus or minus 1 milliliter and 1, 2, 3 significant figures. Your homework for tonight has some math problems just to get used to how to do simple algebra for this class. Some scientific notation problems, which if you're not sure or remember how to do scientific notation, I'm sure there's an internet site somewhere that will show you how to put things in scientific notation or put them back in regular notation or standard form. But the big part of the homework tonight is those rulers. So your job is to look at where those arrows are and just write down the location of the arrow is and tell me the location, which is, let's see, bigger than 2 but smaller than 3, the location of the arrow. Then you'll put a unit, centimeters. You'll put a plus or minus for the uncertainty and the number of significant figures for each. That's due tomorrow.